Hi, welcome to another release of Dogen, the sprint demo. This is Dogen 1.0.24, sprint 24 basically, in Mondeiro do Iona, or no Iona. So, we don't really have a lot of user visible changes as such. I mean, there's a few things that are changed, so we'll talk about those, but it's not really a massive release in terms of user visible changes. But so let's just first talk a little bit about this tracing. Easiest way to demonstrate the tracing is probably, let's have a look. If I just jump over to Dogen, so this guy here, what I'll do is I'm just going to enable tracing on the models here. This is via Dogen's integration with CMake, as you can see here. And what we'll do is we'll just generate Dogen logical dia, which is one of the models. Now Dogen is going to go away and do its generation, and while that's going on, we'll just fire off a shell. So if I just go up to builds, output, release, stage bin. Actually, sorry, not stage bin, just here. Okay, cool. So let's make this a bit bigger so you can see. So in here, as usual, there's the byproducts directory where we always keep all the stuff that we create for each model. And as we decided to generate the logical model, we should look into the logical directory. So that's roughly the timestamp now. Annoyingly, Emacs keeps on changing the font size. So what you can see here, hopefully, I'll just make this a bit bigger, is for each of these transforms, hopefully what you should see is the model name is now within the file name. Now, I'm not entirely sure if it affected every single transform, which might actually be a problem. Let's have a quick look at this. Variability transforms, feature ability transform, variability transforms. Okay, it seems like we picked up a bug here, interestingly enough. Seems like the demo gods are not with us. So it seems like we got the feature, we got the transform name twice here. Now, I knew this wasn't perfect, but I only used this feature for one specific purpose. So potentially, yeah, exactly, that doesn't look right, does it? Okay, let's just try to have a look at what we've got on, say, injection, for instance. And in injection, hopefully you can see here that the model name is correctly placed. So I think the problem there is that on that particular transform, we incorrectly named the model name. Instead of the model name, we're actually printing the transform name. So let's just keep track of where we were. Variability transforms. So if we just add this to the sprint log, this is exactly how Dogen development happens. So whilst we're not actually demoing the feature itself, we're demoing the purposes of the Dogen development. We could type something like check name of model for variability transform, and this is sufficient for us to then populate the story correctly. Okay, so basically the key point of the story is that in most transforms, sadly not the ones we were talking about here a second ago, but in most transforms, the model name is now part of the file names of the tracing dump, and as usual, you can just use things like JQ to help parse these files. So if I now do JSON mode, you got the usual powerful sort of Emacs integration, enabling to filter and do all sorts of things that you can do in Emacs with JSON, which appears to be a bit slow today. 9 megabytes, not the biggest file in the world, so should have been a bit quicker. There you are. So that is that feature. It's just the ability to help with the tracing. The second feature, primitives use compiler-generated default constructors. Okay, so this is a change to the generated code. So if I just jump over to one of the primitives that are already got here. So as you can see here, the primitive there is showing a default constructor was manually generated. Well, code generator should I say, because manually generated sounds like it did by hand. It's actually the code generator that did it. So if I have a quick look at how this used to look like before, you can see that these were compiler generated. You can see here, I'll make it a bit bigger again. So the compiler in the past was generating constructors for these types. Now the problem with that is that when you define the primitive normally could be over a simple type, a built-in type like bool and so on. And for those cases, the compiler default constructor is not good enough because it's not going to call the default constructor of the built-in type. So with this fix, we now are actually creating a proper constructor that does do the correct initialization of the value. So that was good. It was picked up by Valgrind. And another thing that was also picked up by Valgrind, which is not quite well spelt over them, but is the case of circular references. So if I go over to node.hvp, you can see that this structure, which used to be compiler generated, but actually code generated, but now it's handcrafted, and that's why you have so much commented out code here. This data structure was creating a circular reference because, as you can see here, we have a pointer to the parent, and we also have a pointer to the children. So that basically meant that we end up with types that are sort of creating a cycle. And when you create these kind of cycles, then as far as I understand it, Boost's share pointer would not be able to deallocate memory correctly. So you end up leaking by cycles. So in this case, you just have to decide which one is the strong pointer and the weak pointer. And Boost then knows that the weak pointer is the one he doesn't have to deallocate, so it breaks the cycle. So the fix was basically to change that. So from a user visible perspective, all you should see is a fix for a sort of a memory leak. Of course, you probably did notice there was leak there before, but we did notice there was leak there before, because Dogen executes so quickly and just exits and frees up all the memory. At exit, we don't really tell, can't really tell. But if we had like a long-running service, this should have been quite obvious by now. Finally, we also have the problem with allowing creating models with no decorations. So for this, what we'll do is we'll just quickly hop over to our sanity model, which is distributed with Dogen. Well, it used to be distributed with Dogen. Now that I say that, perhaps it is part of the models directory. Let's have a look. Yeah, it is part of the models directory. So let's just try to explain what the problem is. So if you compare this model with a Dogen model that we use in our code, you can see this is a very bare model. It doesn't have any profiles, and it just well, let's make it a bit bigger so you can see. Perhaps a bit too big. Well, actually, it doesn't really matter. So this model here doesn't really have any profiles, and so everything is defaulting, including decorations. Now, if you remember, what do I mean by decorations? So if you remember, we have a profiles model, which is this chap here, and in the profiles model, let's go for 100% because it's a bit of a bigger model. So in the profiles model, you can declare many things, much of the variability and parameterization of the model. Part of what you can declare is the decoration. You can declare whether you've got decoration or not, whether there's a license, whether there's any model line information, whether you want a copyright or not, what copyright would you like. So for example, in this particular case, copyright is this chap here, and so on. So this is all declared under as part of our variability in the profiles. And then of course you make use of that in each of the individual models by referring to the profile, like as you can see here. However, because we wanted to sanity check, we wanted the simplest possible model, we didn't add any decorations. And really, that should be fine. You should be able to have a model that doesn't have any decorations and it just uses default values. However, because of how things were set up, this actually caused the Dogen to crash, because we did something really silly with a pointer somewhere. Now with this release, we fixed the underlying cause that didn't allow us to detect this, which was the sanity check scripts that ensured that the packages work, by generating the hello world model after a build in Travis were not being picked up correctly. Because they were not being picked up correctly, we didn't really see that this chap here was no longer generating. So with this release we introduced a fix for that, introduced a fix for the package, so that we are now sanity checking packages, and fixed basically the mop-up of all of that stuff. So that is kind of it for user visible features. Maybe I'll just take a couple of minutes to talk a little bit about the generation cleanup, which is becoming more and more misnamed as we go along, given that the generation model is long gone now. So we still have sadly quite a lot of work to go in the generation cleanup, although we're doing quite a lot of good progress. So the idea is that we want to get rid of all these types you see here. Let's just go back to 100% here. All these types that are technical space specific, but shouldn't really be. So locators and a few transforms we still have, dependencies, some transforms from the back to the day when we didn't even call them transforms, adapters, helpers. There's all sorts of stuff here. Half of these things should really be generalized and moved up, so to this new model called text, and the other half should really be moved to PDMs and that kind of thing. So this is a long sort of complex task, and it's taking us quite a few sprints to get there. But the good thing about it is that we seem to have got to a point now where at least the architecture for it seems to be clear. Much of the physical model has been extended to cope with those use cases. The models and the names and the interfaces all seem to be coming together, and hopefully what we should see next sprint is that at least the generation of archetypes, which is these chaps here, which is, you can see the change of colors here is already signifies we're moving in the right direction. So archetypes such as backend and facets, parts, and even archetypes themselves should start to get generated with the next sprint. And once we got those generators kind of going, that then basically means that we have the physical model is then kind of capturing all the required information to start for us to start tackling those types. There's a myriad of types we still have here. So it's conceptually, I think we're getting quite close. In terms of implementation, you know, how long is a piece of string really? It could take us another 2 or 3 sprints. It could take us just one. I probably am more inclined to think it will take us a couple of sprints, to be honest. But as a programmer, one has to be optimistic, I guess. So yeah, that's what we got for this sprint, and it was actually quite a good sprint, quite an exciting sprint. And the next one is also, I think, will be quite an exciting sprint. That's all for it for today. Thank you for watching.